Hi, let's start with vectors. You need to include vector library to use vectors. Now, our declaration vector type the name. To add elements, use pushback like 3, 2, and 5 we have done here. Now, to print the values, use name and index of element. Okay, here we use for loop to traverse it. Another method is to use auto and the name of variable, then vector name. Now another vector here. Now we will use back to show the last element and pop back to remove the last element. Now other type of declaration is vector a comma b, where a is a number of elements filled with b. If only given a, then b is equals to 0. Now the output is shown as here. As you can see, the output is as we expected. Okay, now after this let's move on to another important element which is included in STL library, pairs. So as you can see, declaration involves two type parameters, then name. To access them, name dot first and name dot second. This is how we use pairs. As you have seen the output, the next is very important library, that is bit/std c++.h. If we use this, we don't have to use any other libraries like vectors. Now we'll discuss sets, how sets function. We define sets similar to vectors. We use here dot insert instead of dot pushback and dot count. In the parentheses we use the element. If 1, then present. If 0, then absent. We cannot use indexing here. Now to do the traversal, we use for loop with auto like in vectors. As you can see, the output is as we expected. Now we start with stacks. 3 things here in big O of one time: add to the top, remove from top, and see the top element. Use dot push, dot pop, and dot top for this. Here's the output. Now let's discuss queue here. It has two big of one operations: adding to the last, removing the first, and can only access first and last. We use dot push, dot pop, and dot front here. The output here is which we expected, 3 and 2. Next is priority queue, which supports insertion and retrieval or removal of max or min element. Insertion is big O of log n and retrieval is big O of 1. By default, element here are stored in decreasing order. We use here dot push, dot top, and dot pop here. For the priority queue, supporting finding and removing smallest element, we use this declaration. Now policy based data structure. Here we include this library and the namespace GNU PBDS. The declaration involves type def tree, then this types, then in the name. Dot insert is used to insert the values. Dot find by order is used to find the element at the position. Dot order of key gives the position of the given element. Here we use auto, then the variable name, then find by order or order of key. After this, both functions are in logarithmic time. As you can see the output here also. Sets are like vectors. Here also we have the same function, dot insert to insert the values, dot count to count the frequency of element, and dot erase to erase the element. And now let's see the output here. And here it also uses bit/standard c++.h library. As you can see the output. Map has a key value pair based on balanced binary tree. Accessing takes big O of log n. Here map type of key and type of value. Then map key name is equals to value, no value, then it is 0. Now here we use dot count to check the existence of key. And now for iteration we use auto, dot first for the key and dot second for the value. Iterators are variables that points to a data structure. It is half open. Its beginning it's inside the data structure and ends lies outside. Now iterators are used using loops and cout. We use dot find to find the element. Dot find to find the element. If it doesn't exist, then we are pointed to the end of the iterator, that is outside data structure. Here's the output of how it works. DQ is a dynamically resizable in both sides. Like vectors, we have dot pushback and dot popback, and also we have dot push front and dot pop front. And here we can see as the code to implement is bit set arrays with binary numbers only. Here's how to implement these like arrays. Bit set, the benefit is less memory and the values can be handled with bit operations. Now here the different ways to implement bit set it, and here we can also use bit operations. Let's see the output, how it works. Finally, like, share, and subscribe for more topics, and do suggest in the comment which topics would you like to learn in less than 6 minutes.